So, hello Year 10, and hopefully you enjoyed the last lesson where we were testing for cations. Not surprisingly, this time we are testing for anions. And technically this is lesson 6 in the series, although some of you are doing it in a slightly different order. So let's just remind ourselves of what you did last time. So two unknown white substances need to be tested by a lab. Substance A produces a yellow flame, whereas substance B produces a lilac flame. Both substances produced a gas when they reacted with a dilute acid. The gas is tested with lime water and produces a cloudy solution. Identify the two substances. Okay, have a think about that. Right. What produces a yellow flame? Well, hopefully you know that a yellow flame is produced by sodium. It produces a yellow-orange flame. A lilac flame is produced by potassium. The gas is tested with lime water to produce a cloudy solution. Well, you should recognise that as carbon dioxide, CO2. What sorts of substances actually produce CO2 on reaction with an acid? Well, since year 8, you know that carbonates produce carbon dioxide when they react with an acid. So substance A is therefore sodium carbonate, while substance B is clearly potassium carbonate. And if you work those out, very well done. That's exactly what you need to be doing in this topic. Here's some exam questions. These are the most straightforward ones. So this is a level 1 exam question. Nice and easy, but it will test your factual knowledge. Solutions of copper 2 ions and iron 3 ions produce coloured precipitates with sodium hydroxide solution. Draw one line from each metal to the colour of the precipitate it produces. So copper 2, hopefully you're ahead of me. Copper 2 produces a blue precipitate. What colour precipitate does iron 3 produce? I'm hoping again you are ahead of me, and you know that iron 3 produces a brown precipitate. What produces a green precipitate? What produces a white precipitate? If you don't remember, go back and have a look at last lesson. Sodium hydroxide solution was added to a solution containing ions of a metal. A white precipitate was produced. The white precipitate dissolved in excess sodium hydroxide solution. The ions in the solution were what? Well, it's clearly not potassium, because potassium doesn't produce a precipitate with sodium hydroxide. Both aluminium and magnesium do produce a white precipitate, but only aluminium redissolves. So the ions in the solution were aluminium. Low sodium salt contains sodium chloride and potassium chloride. A student used a flame test on low sodium salt. What is the colour produced by sodium ions in a flame test? Yellow. What is the colour produced by potassium ions in a flame test? Lilac. Why is it not possible to tell from the flame test that both ions are present in low sodium salt? If you've been paying attention, this should be no problem. The fact is that the sodium would hide the pale lilac from potassium. So sodium is a very intense bright yellow colour, potassium is a pale lilac, you wouldn't see. So let's just have a quick look at the mark scheme. Copper 2, blue precipitate, iron 3, brown precipitate. Aluminium is the white precipitate that redissolves. Sodium produces a yellow flame, that's what the exam would prefer. It says in this case allow orange, although if you really have to, yellow-orange is the safest thing to cover all bases. Potassium produces a lilac flame, allow purple, doesn't always, but in this case the mark scheme is allowing purple. And why wouldn't you see both? As we said, one colour masks the other. You could talk about getting a mixed colour that you might mistake for something else. So you might mistake it as a reddy orange or something like that. A reminder of the other thing we looked at, which was writing ionic equations. Most metal hydroxides are insoluble. This can be used as the test. So iron 2 chloride solution plus sodium hydroxide solution forms iron 2 hydroxide precipitate and sodium chloride solution. If you want to challenge yourself, pause the video at this point and see if you can write the ionic equation. If you're not so confident, the balanced chemical equation is this: FeCl2 aqueous plus 2NaOH aqueous goes to FeOH2 solid plus 2NaCl aqueous. Now all of you should pause the video and see if you can write the ionic equation. Right, well, as we've said before, all you need to do to write the ionic equation is take the precipitate and work out what ions are in it. We know it's iron 2, so it's going to be Fe2+, and we know that there are 2 hydroxides. If we can't remember the charge on hydroxide, we just look here, NaOH. Sodium we know from the periodic table is Na+, it's group 1, so hydroxide must be OH-, and therefore the ionic equation is as follows: iron 2 plus aqueous plus 2OH- aqueous forming FeOH2 solid. It's the ionic equation. And remember, you must always include state symbols for ionic equations. Now on to the new material, testing for anions. As we said, anions, like onions, are very negative. They make you cry. They're the negative bits of a salt. We're going to start by looking at sulfates and halides. Just to remind you, what is a halide? Well, these elements are the halogens, and they are diatomic. So fluorine F2, chlorine Cl2, bromine Br2. They are uncharged. However, when they react, the halogens form halides. These are the ions. These are not diatomic, they go round by themselves. So fluoride F-, chloride Cl-, bromide Br-. And some students, even up to A level, struggle with that distinction. It's very straightforward. The halogens are the elements. They are always diatomic, they go around in pairs. Why? Well, if you think about it, it's so they have a full shell. So fluorine, in order to have a full shell, it needs to pair up. That's why the halogens are diatomic. Why don't halides need to be diatomic? Well, once fluorine has reacted with a metal, it's got an extra electron already, so it's perfectly happy going around as a negatively charged ion with a full outer shell. That's why the halogens are diatomic and the halides aren't. The other ion we're going to look at is sulfate, SO4 2-. If you haven't learnt that formula and charge by now, you really need to do that. So sulfate, SO4 2-. Start off with testing for halides. Halides, like the chlorides here, almost all of them are soluble, as you can see down here, with a couple of exceptions. Lead chloride, lead bromide, lead iodide is not soluble. Silver chloride, silver bromide, silver iodide is insoluble. Now, thinking carefully about what we're going to allow you to do in a lab, what do you think these precipitates might be? Well, we're clearly not going to let you use lead in a chemistry laboratory, so they must be silver halides. So this must be silver chloride. This must be silver bromide. If silver nitrate solution is added to a solution containing halide ions, then a precipitate is formed. And happily, the colour of the precipitate will tell you which halide was present. A white precipitate tells you that chloride ions were present. A pale cream precipitate tells you that bromide ions were present. And a yellow precipitate tells you iodide was present. You do need to know all of these, so you are at some stage going to have to learn all of these colours and the ions that they indicate. I have shown here the 3 ionic equations for their formation, and they're very straightforward, but just notice that silver ion is 1+, Ag+. It's the exception to the rule. Most transition metals form a 2+ ion. Silver forms a 1+ ion. As it says here, often nitric acid is added before the silver nitrate, and this is used to remove impurities that could give a false positive. So you might hear it referred to as acidified silver nitrate. And that is to stop hydroxides and carbonates giving a positive result in the test. A question for you to think about, I'm not going to tell you the answer, but why would it be silly to use hydrochloric acid in this test? And here is Mr. Reeves doing that test for you. So in this video, we're going to be looking at identifying anions, the negative parts of a salt. And here you can see we've got 3 solutions: potassium chloride, potassium bromide and potassium iodide. And because they all contain potassium, you know that any differences are going to be due to the negative part of the salt, the halide, the chloride, the bromide and the iodide. And we're going to be testing these 3 solutions using silver nitrate solution. But we're also going to be adding nitric acid. And this is to make sure that any impurities are removed from the solutions before we test them. So the first thing Mr. Reeves is going to do is add a couple of drops of nitric acid into these solutions. And I want you to think about why we might be using nitric acid rather than other common acids. Mr. Reeves is now going to add a few drops of silver nitrate solution to each of these, starting with the chloride on the left. And we can see a lovely white precipitate being formed when silver nitrate solution is added to a chloride, in this case potassium chloride. Now for the bromide. Now, when these two are compared, it is obvious that the bromide is a creamier colour. If you just saw the bromide in isolation, it would be quite difficult to say that that was cream rather than white. But when seen next to the chloride, it's obvious they are very different in colour. Now for the iodide on the right. Well, this time there's no mistaking the fact that that is a yellow colour. And so what we see there is adding the silver nitrate solution to the chloride, gives us a white precipitate, to the bromide, gives us a cream precipitate, to the iodide, gives us a yellow precipitate. Thank you very much, Mr. Reeves.
My pleasure.
Okay, the next anion we're going to learn about is how to test for sulfates. Again, just like the chlorides, most sulfates are soluble with a few exceptions. Barium sulfate is insoluble. Calcium sulfate is slightly soluble. And lead sulfate is insoluble. What do you think this precipitate might be? Well, again, we're not going to let you play with lead in the lab. So this is going to be barium sulfate. So how does this test work? Well, if we add barium chloride to a solution containing sulfate ions, we get a white precipitate of barium sulfate. We often add hydrochloric acid first. Why? Why do you think we add hydrochloric acid before the barium chloride? Well, just as we saw on the last slide, this is to remove impurities. Or to stop false positives. As we can see here, barium carbonate is also insoluble, as is barium hydroxide, and therefore, if there's a carbonate or a hydroxide, they would give a precipitate. We don't want that, so we add hydrochloric acid first. Question for you to think about: why would it be silly to use sulfuric acid in this test? And this is really high level, but if you really want to stretch yourself, what other solutions could we use for this test? We do use barium chloride, but what could we use? And here is Mr. Reeves doing the sulfate test. We're going to demonstrate the test for sulfates at the moment, and we're going to be doing this test on sodium sulfate solution. Try saying that many times. So we're going to put a small amount of sodium sulfate solution into a test tube. It doesn't have to be a huge amount. You don't need to go overboard with this. A centimetre's depth is more than enough. Now we're going to add some hydrochloric acid to this. And that's just to remove the impurities. Have a think, which acids wouldn't be sensible for use in this test? So we're adding some hydrochloric acid simply to remove any impurities, and then the important reagent is barium chloride. And again, we only need to add a few drops of this. We can do this with very small quantities, and as the barium chloride is added to the sulfate solution, we end up with a lovely white precipitate that is diagnostic of a sulfate solution. Thank you very much, Mr. Reeves.
That's my pleasure, Dr. Nixon.
The very final test that you need to know for C8 is testing for carbonates. Now, we've already actually looked at this many times, but I'm just going to formally tell you that we can test for carbonates by adding an acid. And you know from year 8 that an acid plus a carbonate makes a salt plus water plus carbon dioxide. One of the gas tests you need to know is how to test for carbon dioxide using lime water. So here we go. We add acid to the solution, and if a gas is formed, we bubble the gas through lime water. If the lime water goes cloudy, the gas was carbon dioxide. If the gas is carbon dioxide, the initial sample must have contained a carbonate. And here is Mr. Reeves one final time doing that test for you. Okay, the final test you need to know for anions, remember those are the negatively charged ions, is the diagnostic test for carbonate anions. And this is going to use, not surprisingly, lime water. You've known since year 8 that carbonates can produce carbon dioxide upon reaction with acids, and so we are going to use that to demonstrate a carbonate. So the first thing Mr. Reeves is doing is putting about 1/3 of a test tube full of lime water into a rack ready to be used, and we're going to do our test on some sodium carbonate solution. So again, we don't need a huge amount of this reagent. So putting some carbonate into that test tube there. Now we're going to add some acid. And as you should remember from year 8, acid and carbonate, there you go, lots of fizzing, gas being given off. That gas is carbon dioxide. So Mr. Reeves is sucking up the gas from the test tube on the right with a pipette, and he is bubbling it through the test tube on the left. Notice he's not going into the solution, he's sucking the gas from the top of the test tube, and the test tube on the left, the lime water, is going unmistakably cloudy here, indicating that carbon dioxide is being produced in the test tube on the right, and that is how we test for carbonates. Thank you very much, Mr. Reeves.
Again, my pleasure, Dr. Nixon.
Now you have all the tests at your disposal, we can start asking some of the more interesting questions. A white substance needs to be tested by a lab. The substance, when in solution, produces a white precipitate with sodium hydroxide. What does that mean? So a white precipitate with sodium hydroxide. But that redissolves with excess or more sodium hydroxide. A separate solution of the substance is added to acidified barium chloride and a white precipitate forms. Identify the substance. And this is the sort of question you will get in an exam. So, what does the white precipitate mean with sodium hydroxide? It means it contains magnesium, aluminium, or calcium. However, we're told that that precipitate redissolves in excess sodium hydroxide, meaning it must contain aluminium 3+ ions. A separate solution of the substance is added to barium chloride and a white precipitate forms. Well, barium chloride is used to test for sulfates, SO4 2-. So, what is the substance? It is aluminium sulfate. It doesn't ask for this, but what's the formula? Well, if you've got Al3+ and SO4 2-, we've got a 3+ charge and a 2- charge. Well, that means that the formula must be Al2 SO4 3. And that is how you do this sort of question. Giving you the opportunity to do some work now. Barium chloride solution reacts with copper sulfate to form a white precipitate, which is barium sulfate and copper chloride solution. Write the word equation, write the symbol equation with state symbols, and complete an ionic equation. Silver nitrate solution reacts with sodium iodide solution to form a yellow precipitate, AgI, and sodium nitrate solution. Complete a word equation, complete a symbol equation with state symbols, complete an ionic equation. I very strongly suggest you attempt this now, because this is where you need to find out whether you can or can't do this. So do pause the video, have a go at these, and then restart. Okay, the word equation here. So barium chloride plus copper sulfate forming barium sulfate plus copper chloride. And every single person should have been able to do that. Complete a symbol equation with state symbols. Okay, well, we've given you the formulae, so it's not as bad as it might otherwise be. BaCl2 aqueous plus CuSO4 aqueous going to BaSO4 solid, that's the precipitate, plus copper chloride. Well, we're not given the formula for copper chloride, but it's clear here, we know that sulfate's 2 minus, so the copper must be 2 plus, so Cu2 plus. And we know that chloride is Cl minus because it's in group 7, so it must be CuCl2, and that's the solution, so it must be aqueous. Is it balanced? 1 barium, 2 chlorines, 2 chlorines, 1 copper, 1 sulfate, 1 sulfate. Yes, it is. So now to write the ionic equation, well, we just start with the precipitate, barium sulfate. What goes into making that? Barium 2 plus, barium is in group 2, it's always going to be 2 plus SO4 2 minus, forming barium sulfate. For the second example, again the word equation is given to you, silver nitrate plus sodium iodide going to silver iodide plus sodium nitrate. Complete the balanced symbol equation. Well, AgNO3 aqueous, because it's a solution, plus sodium iodide, NaI, is a solution. Silver iodide is the yellow precipitate, so that is a solid, and sodium nitrate solution. Well, what do we know? Well, we know that sodium is just Na plus, because it's group 1. Nitrate though, do you know the charge on nitrate? Well, not directly, but you do know that silver is 1 plus, so nitrate must be 1 minus, Na plus, NO3 minus. If you forgot silver is 1 plus, then you've got the clue here. Iodine is clearly 1 minus because it's group 7, so silver must be 1 plus. If silver is 1 plus here, then the nitrate must be 1 minus. Okay? So NaNO3 aqueous. And writing the ionic equation, we just need to say what's going to make silver iodide. Clearly it's Ag plus and I minus. And I'm hoping by now ionic equations don't seem so scary. Some questions that I'm not going to go through, but you are very welcome to pause the video at this point and check you can answer these 8 questions. I'm more interested in this. So really do pause the video here and work out what these 5 compounds are. When you think you've worked it out, restart the video and see if you were right. Okay, an orange-red flame test, that says calcium. Calcium should give a white precipitate in sodium hydroxide, which indeed it does. The lime water test, it went milky. This tells us that it is a carbonate. So sample A is clearly calcium carbonate, chalk. No colour in a flame test, but a brown precipitate. Brown precipitate with sodium hydroxide tells us it's iron 3+. No positive test for carbon dioxide. A white precipitate with silver nitrate tells us that that is chloride ions. So B is iron 3, and you do have to specify chloride. C, a yellow flame in a flame test. Well, that's sodium. Doesn't give us a precipitate with sodium hydroxide, as expected. No test for CO2. A cream precipitate with silver nitrate. Well, that is bromide. So this is sodium bromide. A lilac flame in a flame test, that is potassium. No precipitate with sodium hydroxide, as expected. No positive result in the test for carbonate. Nothing in the test with silver nitrate, but a white precipitate with barium chloride. That is the test for a sulfate, SO4 2-. So D must be potassium sulfate. E gives us a green colour in the flame test. That should be copper. It gives us a blue precipitate with sodium hydroxide. That confirms that it's copper. Nothing in the test for carbon dioxide. A yellow precipitate, that is iodide with silver nitrate. So therefore E must be copper iodide. And nothing in the test with barium chloride. If you got 5 out of 5, very well done. This is an actual exam question. So here are 5 substances, 5 different tests. Again, can you identify what these 5 compounds are? Do pause the video. Do make sure you can do this. Restart when you have an answer for each one. Okay, so white precipitate with silver nitrate says chloride, a blue precipitate, copper, and a green flame, copper. So A is copper chloride. B, fizzes. So adding hydrochloric acid, fizzes, gas turns lime water milky. That's carbonate. A white precipitate that redissolves, that is aluminium. And notice aluminium giving no colour in the flame test. So this is aluminium carbonate. White precipitate with barium chloride solution, that is a sulfate. A lilac flame is potassium, so C is potassium sulfate. D, yellow precipitate with silver nitrate is iodide. A yellow flame is sodium, so D is sodium iodide. A cream precipitate is bromide. A green precipitate is iron 2 plus. You must be specific. Iron 2 plus. And E therefore is iron 2, and you must say that, bromide. And again, if you got all 5 of those correct, very well done. Those of you in my set will almost certainly have heard you sing my way through the 6 tests of C8. I'm not going to give you the full rendition, but just to remind you, this is what you need to know. You won't be given these tests, you need to learn them. So just after Christmas, my teacher gave to me 6 uses for hydroxide, 5 burning splints, 4 gas tests, 3 halides, 2 acid steps, and a test for a metal sulfate. Okay, so 6, 5, 4, 3, 2, 1. 6 precipitates that you need to know for sodium hydroxide. 5 flame test colours, 4 gas tests, 3 halide colours, 2 things you do to identify a carbonate, 1 test to identify a metal sulfate. Make sure you know those. The last question is a 6 marker, and I'm going to get you to spend 6 minutes working out what you think's on the mark scheme. So, a group of students had 4 different colourless solutions in beakers 1, 2, 3 and 4. The students knew that the solutions were sodium chloride, sodium iodide, sodium carbonate and potassium carbonate, but they did not know which solution was in each beaker. The teacher asked the class to plan a method that could be used to identify each solution. She gave the students the following reagents to use: dilute nitric acid, silver nitrate solution. That's it. The teacher suggested using a flame test to identify the positive ions. As it says here, outline a method the students could use to identify the 4 solutions. So you need to describe the methods. You should include the results of the tests that you describe. Okay, so give the results as well. So pause the video, outline how you would identify these 4 solutions. You have 6 minutes. Okay, so let's start simply. The potassium carbonate could be identified in the flame test by a lilac flame. All the others would give a yellow flame. So we have identified the potassium carbonate. We have nitric acid. Now what would happen when you added an acid to a carbonate? This would fizz when the acid is added. We don't have lime water, we aren't given that, we can't talk about lime water, but we could identify that because it would fizz when the acid is added. If we were to add nitric acid followed by silver nitrate solution, and we must talk about adding the acid first, then sodium chloride would give a white precipitate, while sodium iodide would give a yellow precipitate. If you talked about adding acid and saying that the sodium chloride would give a white precipitate, if you talked about adding the nitric acid followed by the silver nitrate solution and said that sodium chloride would give a white precipitate, iodide would give a yellow precipitate, and the other 2 wouldn't give a precipitate, that's fine. You have identified sodium carbonate by the lack of a lilac flame and by the lack of a precipitate. That's okay. Okay, so here's the mark scheme. For a level 3, 5 or 6 marks, which is where you should all be aiming, description of the methods used is essential to identify positive and negative ions with relevant results. So have you done all of that? Have you described the methods? Have you identified positive and negative ions? Have you given the results? For example, for the flame test, accept any method of introducing the solution into the flame. So any method of introducing the solution into the flame. So you could talk about using a soaked splint, you could talk about spraying the solutions from a bottle, or you could talk about using a platinum or nichrome wire. But you've got to describe how you do the flame test. The result, the sodium compounds result in a yellow flame or an orange flame. The potassium compounds would give a lilac flame. Student could state that potassium carbonate gives a different colour to the 3 sodium compounds as long as it is clear that the flame test colour comes from the sodium or the potassium. Okay, so you've got to really describe that potassium gives a different colour in the flame test to the other 3 compounds. Here's the test for the carbonate. Add the dilute nitric acid to all 4 solutions. It says allow any acid, and the carbonates will effervesce, they will fizz, or sodium chloride and sodium iodide will not fizz. Test. Add dilute nitric acid followed by silver nitrate. Result, sodium chloride and sodium iodide produce a precipitate, or sodium chloride produces a white precipitate, sodium iodide produces a yellow precipitate, except that sodium carbonate and potassium carbonate do not produce a precipitate. So you should have done quite well. Just note a few things. You did have to describe the tests, and you wouldn't have got all 6 marks if you hadn't done that. You also could not use lime water. So if the question doesn't give you that as a reagent to use, you can't include that in your description of the tests. Well, hopefully that was useful. We're going to continue finishing off C8 in the next couple of lessons, but your homework will involve some of these questions. Goodbye.